Greetings to all of you. The session is regarding intermediate chemistry. This will be fetching for your international entrance or competitive examination you are aspiring for. India level JE Advanced, JE Mains examination, that is entrance into IIT and NIT stream, that is the technical domain, and NEET chemistry for medical entrance examination across India. Telangana and Andhra Pradesh MCET examination, that is the BTech or engineering stream entrance exam, that is again called a technical domain. In addition, if you're aspiring for any government examination, a competitive exam, we can say, where general studies question paper is in common. In that, general science content will be there. You have to go for all kind of science related topics. The content what we are discussing here will be very much helpful in that preparation process. Let's enter into our today's session. Explain isomerism which is present in the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. According to that one, it is called optical isomerism called absolute nomenclature, right? RS nomenclature is also called as absolute nomenclature. So in this absolute nomenclature, the given compound to be assigned with either R or S, and IUPAC name should be assigned in order to give that one. R stands for rectus, S stands for sinister. R denotes if we are going with the higher priority to lower priority in the clockwise dimension, that is called R configuration. If higher to lower priority, if the rotation is carried in anti-clockwise rotation, that is called S configuration. R for rectus, S for sinister, right? So this is the compound assigned where you have to give R and S nomenclature as per the IUPAC protocol. In order to give that kind of naming, first of all, we have to know one important term over there, that is called chiral carbon atom. What is meant by chiral carbon? Are optically active carbon or asymmetric carbon. The carbon which is surrounded with the four different functional groups around, which is said to be chiral carbon. If you see this, a single carbon is accompanied by hydrogen, bromine, fluorine, iodine. These many four different functional groups are surrounding the carbon. Hence, we can say carbon is a chiral. Whenever chiral carbon is taken, so we have to give the priority. Again, we need to go with Kahn, Ingold, Rayleigh rules. CIP rules gives that higher atomic number, higher priority, iodo, bromo, fluoro, and hydrogen. As we are moving higher to first to second priority in this direction, the arrow is moving in a anti-clockwise rotation. Anti-clockwise denote S configuration. S is the absolute configuration for the given organic compound. After giving S, the else will be a IUPAC nomenclature. How can we give? Whenever you are writing IUPAC nomenclature, alphabetical order plays a vital role. In the alphabetical order, B comes first over I, over F, over H. That's the reason why. Let me mention, need not to mention one bromo, one fluoro, one iodo, because the carbon is only one. So that need not to go for numbering over there, right? Bromo, fluoro, iodo, methane we can write. Being it is a carbon one, parent chain will be mether. This is the way entire name will be given. Let me repeat. Yes, bromo, fluoro, iodo, methane. This is the IUPAC nomenclature in terms RS absolute configuration as well. For question number one is bromo, fluoro, iodo, methane is the IUPAC name of the compound. Move on to question number two. Question number two collected from Cambridge Assessment International Education. Ammonia is used in the manufacture of nitrogen containing fertilizer. Ammonia is a starting material for the manufacturing of nitrogen containing fertilizers. Which two of these compounds are present in fertilizers? Okay, so here one of the term they only mentioned themselves. One is nitrogen. Nitrogen very important for fertilizer. Here we have to distinguish what is meant by fertilizer, what is meant by pesticide in terms of agri technology, right? Agri technology denotes what in the agricultural field. Here, fertilizer is the chemical component which used to give the nutrients to the plant in order to nourish, in order to grow, in order to give their flowers, fruits, whatever their yields it might be, right? That is a kind of food material in order to supply nutrient material in order to supply to the plants or crops. Whenever pesticides are taken into the consideration, where the chemical substance we are spraying will kill the disease causing organisms and the crops which are used to avoid the diseases or what any damage causing organisms which are attacking the croplands. Those are called pesticides. Pests are nothing but disease causing, right? So this is the way. In case of fertilizer, the most important components required to give the nutrients to the crops are NPK. N denotes nitrogen, P denotes phosphorus, K denotes potassium. NPK are called macronutrients and which should be supplied in the form of fertilizer. Fertilizer is the kind of nutrient either by natural or synthetic source we can supply, right? So they're asking for starting with ammonia as a for the synthesis of nitrogen containing fertilizer. Which two of these compounds are present in the fertilizer? One of the component they only mentioned nitrogen. After nitrogen we mentioned three macronutrients, and the left will be one is potassium, another is phosphorus. NPK are required, so that they are asking for tick two boxes only. So copper is required and sulfur is required, but in the minute quantity. The components whichever required in the maximum quantity are only three: nitrogen, potassium, and phosphorus. So that clearly mentioned over there. The requirement of nitrogen towards the plants are, this is very essential for the formation of amino acids. These amino acids will be the starting material for protein synthesis. These are called building blocks for the protein synthesis. Right, for the plant growth, so these are called growth factors. Nitrogen containing proteins are called growth factors. Cell division is possible and plant growth is possible. Directly involves in the photosynthesis. Photosynthesis is a kind of mechanism of chemical reaction in the presence of light in order to synthesize their own food is called photosynthesis. Necessary components of vitamins, production and use of carbohydrates. So in order to consume the vitamins and carbohydrates, nitrogen is essential. Affect energy reactions in the plant. Whatever energy related transformations are possible, presence of nitrogen is very essential. Move on to phosphorus. The requirement of phosphorus is photosynthesis. So phosphorus involved in the photosynthesis, respiration process, energy storage, energy transfer, cell division, and an enlargement. So many vital biological, metabological activities performed by the phosphorus, like photosynthesis, it involves respiration process where we are inhaling, exhaling, exchange of gases. We can say that is possible by phosphorus. Energy, in order to store the energy and to move the energy from one place to another, and in order to division of the cell and cell enlargement and subsequently growth factor gain. Phosphorus promotes early root formation in growth. Root formation, root system development is carried by the phosphorus. Improves the quality of fruits, vegetables, and grains. Fruit quality, vegetable quality, and grain quality, whatever we are getting the crop, so that the quality of the yield will be improved by the presence of phosphorus. Vital to seed formation, right? So seeds are very essential to germinate, very essential to grow the crops, are very essential to continue the process of that cropping by that seed only, right? So that seed formation mainly altered by this phosphorus helps the plants to survive harsh winter conditions. Whenever harsh condition, that means abnormal conditions are present, where phosphorus plays a vital role in order to overcome that kind of a critical conditions over there. Hastens maturity. So the plant growth can be affected by phosphorus. Next is about potassium. Carbohydrate metabolism is possible in the presence of potassium. Breakdown and translocation of starches. Starch is nothing but carbohydrate, energy bank it will be, right? So just like our bank is for money, here the starch is the bank for energy, right? So that is the way starch carbohydrate metabolism will be carried by potassium. Increase the photosynthesis. It will accelerate. It will increase the process of photosynthesis. Increase water use efficiency. How extent water usage is there, that extent flourishness will be there, right? So that water is very essential for crop growth. Some crops consumes the maximum extent of water. Some crops requires arid lands also, but most of the croplands requires the continuous water supply, so that efficient water usage can be regulated by this potassium, essential to protein synthesis. So in order to synthesize the protein, we need nitrogen, but potassium will facilitate, that means increase the process of that protein synthesis. This is the way nitrogen, phosphorus, potassium plays a vital role and called macronutrients required in the bulk quantity to grow the crops and to give the high yields. So that we can say nitrogen, potassium, phosphorus. These two boxes can be ticked for these fertilizers. For question number 2, option B, option C are the correct answers. Move on to question number 3. Question number 3 is collected from JEE Advanced 2019 question paper, paper 1 question. It is the compound which generates nitrogen gas upon thermal decomposition. They mentioned the temperature in specific below 300 degrees centigrade. Very important, because temperature regulated reactions will be there. Below 300 some extent reaction, above 300 that means extreme high temperatures reaction will be different, low temperature reaction will be different. That's why we have to be temperature specific. Below 300, which of the components are decomposed to give the nitrogen gas? Nitrogen will be evolved. Let me see. NH4NO4, ammonium nitrate. The second is NH4 taken twice Cr2O7, ammonium dichromate. And this is called barium azide, BaN3 taken twice, barium azide. And this is called magnesium nitrate. So these many compounds upon heating less than 300, where you can see nitrogen liberation. All the compounds, if you clearly observe, nitrogen containing only. But where nitrogen gas is purely evolved, we have to identify. The expected answers are B and C. Multiple options are provided. B, C to be the correct answer. Let me check. How can we get this? In order to get that one, ammonium nitrate, first compound, option A compound is ammonium nitrate. Ammonium nitrate when decomposed at less than 300, nitrous oxide, N2O is called what? Nitrous oxide, and another is water. So N2O and H2O is generated but not N2. That means nitrogen gas is not evolved. So A is wrong option. When ammonium dichromate when heated at less than 300, nitrogen gas evolved, put a tick mark. Then barium azide upon heating, barium plus nitrogen, again put a tick mark. So that it is also correct answer. Then magnesium nitride will not get decomposed below 300. So that we can cancel out this. Only B is evolving, C is also evolving. Where clear information is there, ammonium nitrate decomposed to give nitrous oxide, water. Then ammonium dichromate upon decomposition, thermal decomposition we can say. Decomposition in the presence of heat is called thermal decomposition. So that we will get a nitrogen gas, chromic oxide, and water will be generated. So these are the products. And next is about barium azide. Barium azide upon thermal degradation, barium plus nitrogen. This is the reaction where nitrogen evolved, but we are saying nitrogen not evolved for magnesium nitrate. This is applicable above 300 degrees centigrade. This decomposition is possible, but below 300 degrees centigrade decomposition is not possible. We should be temperature specific. They're asking for less than 300. Less than 300, no nitrogen. So correct options are B and C only. If This below 300 is not there. B, C and D also correct. Okay. But below 300 gives only B and C. So for question number 3, option B, option C are the correct answers. Move on to question number 4. Question number 4, the correct statements regarding binary transition metal compounds is binary transition metal compound, correct statement to be identified. Atomic number of iron is 26, nickel is 28. Okay. Total number of valence shell electrons at the metal center of iron pentacarbonyl, nickel tetracarbonyl are 16. These are predominantly low spin in nature. Metal carbon bond strengthens when oxidation state of the metal lowered. The carbonyl CO bond weakens when oxidation state of the metal is increased. These are the given options. Expected answers are only B and C. A is wrong, D is wrong, B, C are correct. Let's see how can we explain this. First of all, they are saying about binary transition metal carbonyl. Binary transition metal carbonyl means binary metal carbonyl compound consists only metal and carbonyl ligand, usually prepared by direct reaction. Binary means binding of metal with the carbonyl. That's it. Okay, metal bonded to the carbonyl under powdered form at highly reactive metal can be taken, and carbon monoxide is treated. Metal salt will be generated, zero valency followed by reaction with high pressure carbon monoxide. Simply, binary metal carbonyls are nothing but binding pure metal with carbon monoxide at elevated temperature conditions, right? Without any kind of transformation, directly binding metal with the carbonyl if possible. That is called a binary metal carbonyl compound. For that purpose, they are saying that total number of valence shell electrons of iron pentacarbonyl, nickel tetracarbonyl are 16. Let's check out total valency electrons. How can we calculate? For the metal iron, atomic number themselves they mentioned as 26. For 26 atomic number, valency shell configuration is 4 is to 3d6. So 4 is to 3d6 electrons are there, being carbonyl compounds always having oxidation state 0 around the central metal. This is the fundamental. Whatever the compound in the form of carbonyls will be accorded with 0 oxidation state around the central metal, right? So that iron will be 0, oxidation state around the central iron will be 0. So that valency electron count, how can we calculate? N is to we said, that means 4 is to we said. So s orbital is having 2 electrons and 3d6. D orbital is having 6 electrons. Oxidation state around the central iron 0. That's why let's take all valency electrons as such. 2 from s orbital, 6 from d orbital. And how many ligands are there around the metal? Number of ligands are 5. So 5 ligands are taken. Each ligand contributing 2 electrons. So that 5 carbonyls contributing 5 into 2, 10 electrons. So total valency electrons is equal to S electrons, D electrons plus number of ligands and each ligand contribution. That is 2 plus 6 plus 5 into 2. So 5 into 2, 10. 10 plus 6, 16. 16 plus 2, 18. Then nickel carbonyl is also having 18 electrons. How? N is to NP8. That means 4 is to 3D8 is the configuration. So 2 electrons from s orbital, 8 from d orbital, and 4 is the ligand number, and each ligand contributing 2 electrons. 4 2s are 8, 8 plus 8, 16, 16 plus 2, 18. But they are saying total valency electrons are 16. When you are calculating, it came as 18. So that this is the wrong one, mentioned with the wrong statement. And second, they are saying all the compounds are low spin in nature. And these are made up of what? Carbonyl and carbonyl only. So if you observe the spectrochemical series stands for ligands if arranged in increasing order of their strength. all the ligands are arranged with their strength. So greater the strength, they are first. Least the strength, they are okay. This is the order we observed. Among the entire order, CO mentioned at the first position. CO for what? Carbonyl. If carbonyl is having higher strength, always they have higher power to make low spin complexes. So that both the carbonyl compounds are low spin in nature because the strength of ligand is strong. They are called strong field ligands. Hence, the formed complexes are low spin in nature. This is the fundamental. And metal carbon bond strengthens when oxidation state of metal is lowered. For example, metal is +2. So, and metal is +4. So, what we can say? uh, Metal carbon bond is strong in metal in +4 oxidation state over +2. So that higher the oxidation state, sorry, lower the oxidation state, higher will be the strength. Oxidation state of metal is lowered, strength of the bond will be increased. Inverse proportionality, right? And carbonyl carbon bond weakens when oxidation state of metal is increased. This is wrong one. Oxidation state of the metal increased, carbon oxygen bond will not be changed. So the D is wrong. What they are saying in B, what they are saying in C are correct. A is wrong, D is wrong. In A, you are getting 18. In D, carbon oxygen bond will not be altered by oxidation state of the metal if changed. So B, C are the correct answers. For question number 4, option B, C are the correct answers. Let me give the entire solution. Iron pentacarbonyl nickel tetracarbonyl complexes have 8 electrons in their valency shell. Just now we counted Ns2 Np6 for iron, Ns2 Np Ns2 Np8 for nickel. So that the iron pentacarbonyl nickel tetracarbonyl complexes are not having 16 electrons, rather 18 electrons will be there. Carbonyl complexes are 100% said to be low spin in nature because higher the strength of carbonyl, because these are called strong ligand field. As the electron density increases metal with the lowering oxidation state, the extent of synergic bonding increases, metal carbon bond strength increases, right? So electron density increases on the metal, metal carbon bond strength also increases, right? So that lowering the oxidation state, greater the strength of metal carbon bond. Okay. While positive charge in the metal increases, extent of synergic bond decreases, carbon oxygen bond stronger, not weaker. So D is the, what they are saying is not correct. So weaker is a wrong one. So B, C are the correct answers. Question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination, right? What is the lambda max value of the following compound? This is the question given from spectroscopy analysis, especially in UV visible spectroscopy. Lambda max values are given for UV visible spectroscopy. The compound is provided where it is having alpha beta unsaturation and homoannular conjugation as well. Threefold conjugation you can notice, and there are side chains like methyl and ester. So for this compound, how can we go for calculation of lambda max values? The expected answer we need to be calculated as 302 nanometers. In order to calculate, there are specific guidelines which are called Woodward-Fisher rules. Woodward-Fisher rules for the given any unknown compound is given to you. There are certain values in the absorption of lambda max values so that you can go for the calculation. Okay, according to Woodward Fisher, so if we are having cyclohexadiene, this is called cyclohexadiene. Cyclo means a ring system, hexa means a six-membered, diene means a six-membered ring with two double bonds. In that case, 260 nanometers is the value. So here cyclohexadiene, the value will be 260. Then alkyl substituent is there. That alkyl substituent will be accorded with 10. If ester is there, that will give 0. Ester will not give any UV visible value. And if double bond extending conjugation, this double bond extended with another conjugation, no? So that let me add one more 30. So this 30 is also added. So let me add all the values. 260 for cyclohexadiene, alkyl will give 10, acetate 0, double bond extending conjugation is 30. If you add, the entire value will be 300 nanometers. So the given compound will give 300 nanometers near to 302. So that for question number 5, option number 1 will be the correct answer. Move on to question number 6. This question number 6 is collected from TS MSET 2023 question paper. Okay. So match the following. ఈ క్రింది వాటిని జతపరచుము. List 1 with list 2. And this is the question purely from biomolecules in specific amino acids. There are 20 amino acids in the nature, and these amino acids, 21 amino acids in nature. So some are called essential amino acids, some are called non-essential amino acids. And another classification, some are called acidic amino acids, some are called basic, some are called neutral, some are called aromatic amino acids. These are so many amino acids are present. Why we need to study about amino acids? Because amino acids only required to be synthesized proteins required for the living organism growth. Okay, so all these are amino acids and their nature will be given. Glutamic amlamu, glutamic acid, lysine, valine, tyrosine. So these are the compounds. Aromatic amino acid, aromatic amino amlamu. Neutral amino acid, tatastha amino amlamu. Basic amino acid, ksara amino amlamu. Acidic amino acid, acidic amino amlamu. So the compounds and their nature to be mapped. For that, let's see one by one. Glutamic acid is given as COOH, NH2, CH2, CH2, COOH. This is the one, this is the compound where we have two carboxylic acids, which is called glutamic acid. Two carboxylic acids are there, one NH2 is there. NH2, COOH get cancelled because one is acid, one is base. If you are cancelling acid and base, and the left will be COOH, means one of the COOH is excess. That's the reason why we can say the compound is acidic in nature. So this glutamic acid is saying I am acidic compound. So acidic is given. Where acidic is given? Option number 4, acidic. So acidic amino amlam. So A will be mapped with 4. Move on to second. Second compound is COOH, CH, NH2, CH2, 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 NH2. Okay. If you observe the entire compound, one COOH, one NH2 is cancelled out. And if you cancel this acid with base and another NH2 is there, if NH2 is excess, we can say I am basic. The lysine is saying I am basic compound. Why lysine is saying I am basic? Because excessive NH2 is present. So the COOH nature compensated with NH2, but another NH2 is there which will facilitate the basic nature. So that lysine is saying I am basic. Okay. Move on to valine. This is called val. Where is valine? Valine. This is called valine. So where valine can be signed with a COOH, CH, NH2, CH, CH3, CH3. So this is the compound. If NH2, COOH cancelled out and no acid, no base is there. NH2 is not there, COOH is not there. So that we can say it is neutral. Valine is saying I am neutral because one NH2 will compensate with one COOH. Both the nature got cancelled equally. So no other acid or base in that. So valine is saying I am neutral. Can you find neutral anywhere? So option C can be mapped with the neutral amino acid, tatastha amino amlam. So C with the 2. Move on to tyrosine. Tyrosine is given with Benzene ring containing CH2, CH, NH2, COH. On this benzene para position, hydroxy will be there. Para hydroxy, benzene, and here you have CH2, CHNH2, COOH. Okay, so if you cancel COOH with NH2, so these will be cancelled and the leftover will be uh, benzene ring with OH. What this tyrosine is saying, I am aromatic. Any compound is of benzene related, benzene containing, that is called aromatic in nature. So that we can say tyrosine is a aromatic compound. Hence it is saying I am aromatic. So tyrosine is an aromatic amino amlam. So they can be mapped with 1. Glutamic acid acidic, lysine is basic, valine is neutral, tyrosine is aromatic. This is the way we can go for mapping of options in list 1 with list 2. For question number 6, glutamic acid acidic, lysine basic, valine neutral, tyrosine aromatic. By this, the detailed explanation is provided for various sections, various dimensions of chemistry in the perspective of entrance and competitive examination. And the data is collected from various authenticated organizations. And the entire information is very much fetching for your entrance and competitive examinations. Hopefully, those who are practicing these will definitely move to improve their chemistry interest and thirst of getting more such kind of content in the near future. That's the reason why I'm sincerely requesting to like the channel, comment which is important for your preparation, share with the aspirants who are serious about exams, and subscribe the channel to receive more updates. Thank you one and all.